In this video, we want to look at how do we find inverses of functions. So we've talked about this before. You've got the easy way and you've got the easy way. Okay, so let's do it the easy way. So to find the inverse, the first thing you want to do is rewrite f of x as y. So y equals 8x plus 13 divided by 5. And then you want to rewrite the x for y's and y's for x. So y becomes x, and the x becomes y. Once we do this, it's a matter of solving this equation for y. So to solve for y, the first thing you want to do is get rid of the fraction, which is to multiply both sides times 5. And we get 5x is equal to 8y plus 13. So we finish getting y by itself by subtracting 13. So 5x minus 13 is equal to 8y, and then one final step to get y completely by itself is to divide both sides by 8. So y is equal to 5x minus 13 divided by 8. And then the very last step for converting to the inverse is to rewrite y as f inverse of x. So this is how you would write the inverse of that function. Now I said that was the easy way, right? Step by step, you undo everything and you get y by itself. Well, here's the other easy way. If you start off with x and you follow the order of operations, well, what would you do here? You plug in a value for x, and the first thing you would do between using the 8, the 13, and the 5 is that you have to multiply times 8 first. And then after you multiply times 8, you would add 13. And then after that, you would divide by 5. Those are the steps you take if you're just plugging in for the function. The inverse is supposed to do the steps in a backwards order with the inverse operation. So let's go backwards. So if I start with x, let's take each of these steps and do the inverse. So the inverse of dividing by 5 is to multiply times 5. The inverse of adding 13 is subtracting 13. The inverse of multiplying times 8 is to divide by 8. And if you put all of that together, you end up with this for your function, for your inverse. X times 5, so that's 5x, minus 13, and then you would divide everything by 8. So either way you do it, you get the same answer. Now, I prefer what I did there on the right because it's a little bit faster, but you have to know your order of operations. You have to be very careful. And this trick only works if you have just a single instance of x. If there's x in both the numerator and denominator, it definitely makes things a little bit more challenging, and you can't do that little trick. All right, the next one that we want to look at is this. So if we are given that f of x is equal to 5 times the cube root of 4x minus 7 plus 9, let's find the inverse. Now, I'm going to use my little shortcut because it's going to be a little bit faster. But you can always do it the longer way, the way the book describes, or the way you would do it in my math lab, but it's still going to be the same answer at the end. You just have to make sure you follow the order of operations. And really, if you can solve, like back up here, if you can solve this guy for y, you can follow the order of operations. You know what to do. So when you plug x into this function, the first thing that you would do is to multiply it times 4. And after I multiply times 4, so you get 4 times whatever, the next thing that happens is not any of the stuff that's on the outside, but it's what's next to it. You've either got the cube root or the minus 7. Well, the cube root applies to this whole guy right here, so you have to do the minus 7 first before you can apply the cube root. And after you apply the cube root, do you multiply times 5 or add 9? Well, the 5 is stuck to it, it's connected to it through multiplication, so you do multiplication with 5, and then at the end, you're going to add 9. So a lot of steps here, but to find the inverse, you just go backwards. Alright, so if I start with x, let's go here. The first thing I see is to add 9, so I've got to undo that. I have to do the inverse. So it means I would subtract 9, and then the inverse of multiplying times 5 is to divide by 5. The inverse of doing a cube root would be to raise the expression to the third power. That's how you would undo that. How do we undo subtracting 7? It's adding 7. And then the inverse of times 4 is division with 4. So we have 1, 2, 3, 4. We got 5 steps that we have to do. So let's go ahead and write this piece by piece. Whoops. F inverse of x. And let's see what we get. So it's x minus 9. So x minus 9. Divide everything by 5. Divide everything by 5. Cube the entire expression. So cube this. Add 7 to that. So just add 7 out here. Then divide everything by 4. So take this whole guy and divide by 4. So there you go. It's a complicated mess, but let's keep it this way. Don't be tempted to try to cube out x minus 9. It's not going to go anywhere good for you. Just trust me on that. So this is finding the inverse of functions. Now I'm going to change this up just a little bit. So instead of asking you to find the inverse itself, instead of me giving you the actual function, suppose I just give you information about a function. Okay. So you were given a one-to-one function, and what do we know about it? Well, we know that this one-to-one function has a domain of -5 to infinity. It has a range from -infinity to 17. It has an x-intercept of 9, 0, and it has a y-intercept of 0, 4. So if you were given that information about a one-to-one function, what could you say about its inverse? Okay, so the question here is, what do we know about its inverse? Well, remember the big thing about going from a function to its inverse is that x becomes y, y becomes x, which means the domain here corresponds to my range. So my range would now be -5 to infinity. And what was my range for my original function is going to be the domain for the inverse. So my domain is going to be from -infinity to 17. Now, that's just a simple switcheroo for your domain and range. Your x-intercept, okay? Your x-intercept here becomes a y-intercept. Now, this is where things get a little bit trickier. It's a y-intercept, but since we're talking about an ordered pair, the order flips around, so it becomes 0, 9. And if you have a y-intercept for a function, you're going to have an x-intercept for the inverse. And the x-intercept is going to be not 0, 4, because 0, 4 is not even an x-intercept. It would be the ordered pair 4, comma, 0, just like that. Okay? And there you go.